Hi everybody, my name is Ladislav and I'm here with the second video about tilt compensation of AFM images. In the previous one I talked about flatten option, but that's not the only one option how to compensate the tilt. There is also a different tool, it's called plane fit. The main difference between flatten and plane fit is that plane fit is taking the whole image for the polynomial calculation. Not the line as flatten, with the whole image in 2D, not just single line. How to work with that? Very easily. We have something called plane fit icon here, which open a new parameter list. You have two very similar options. One is the order as before. For tilt compensation I will choose the first mode, and then you choose the direction which you want to compensate the tilt, and in our case I will use just the X. If I will continue, you can see it's the tilt is compensated in X axis, but in Y axis it's still dark on the top. So if I will choose XY, it means compensate in both direction. I just click execute. It's it. We just have an image, it's compensated. The question now is it correct? Is it really correct what we want to have it? And unfortunately I need to say you no. Right now I'm opening the section, make a line, and you can see that the minimum on the left side is something like minus 18 nanometers, and minimum here is minus 28, let's say. So there is 10 nanometers difference from the left side to the right side. The reason for that is very similar to previous one, that we have some tall feature, some high feature on right side. You can see that there is a small gap with no feature at all, and then there is a periodic structure. So the tilt take in account the whole point, and it's shifted to the right side. I prepare a second image when I can show you much better what's the problem. This is just one window from the structure, and right now it's okay. There is no tilt at all. If I will click plane fit XY, and you can see now I just introduce some tilt, because there's what's the reason or why is that like that? You have a one top feature which is high enough, and you take it in account during the calculation, and then just lift the bottom right corner up or down, actually this moment down, because this feature is much upper compared to the substrate. So you need to choose, or you need to think about it, and you need to choose your area for the calculation when you don't want to have such a error. With flatten we had something like stop band, which closed, which was possible to use to mark the area which you don't want to use for the calculation. With this option we have something called box. Box means that you draw a box and you will use only the area in the box for the calculation. So if I just click, it will just use this one for calculation and apply the same polynomial for the rest of the image. And that's the way how to do it. That's the way how to correct it when we are talking about the whole complex image like this. You just mark 1, 2, 3 here. You just mark few areas which should be on the same height, should be leveled at the end, and just click execute. That's it. And if I will now open the section, draw a line. You can see, hey, right now it's around 0, and this is around 0. That's how it should be, and now you can easily read the way, easily read your distances, your height, your feature heights, and so on. So that's about the brainfit function. You have also a few other parameters which are very similar to previous one. Generally, you have like again the thresholding, which you can mark the data which are below or above some limit, and you define it with a %, and of course you can mark the data and use it for calculation. So again, the blue curve. You have also here the parameter add higher order. What does it mean? If you have something like second or higher orders, you have a polynomial, and the polynomial is calculated from some x on second power, y on second power, and this parameter just adds a few more polynomial parameters to your polynomial. I will show you in the help, and I will find it. Take a second. Brainfit and fit the polynomial. Yeah, that's the polynomial if you use only for y, x calculation only for y, for xi, and if you check that also add higher order terms, you have a few polynomials, and you can see there's like jx third power, and with this add order you have few more like xy third power and some few more polynomial members which are added to the equation. Generally, yeah, for complex it's better description of the polynomial, but doesn't make any big change. So that's about the brainfit. From my point of view, it's the best way how to compensate the tilt correction, because you can mark few data, show, hey, that's a good part of measurements for substrate tilt compensation, and it's relatively easy with drawing the boxes and get it. So that's it, and I will have a few more points to the section and generally of the options what we are having here, because with brainfit option we have here only the box. With the flatten, which I talked about it in the previous one, right now I'm in flatten, not in brainfit. I have a stop band option, so the difference is that there's a cross, but we have also a few more like cursors type, and the others are in section. The standard is just drawing a line. Yeah, that's it. But you have like, it's going rotating line because you can change your angle. But we have also horizontal line, and I just left click on the mouse and it makes me the whole line from the beginning at and the end of the image. So it's like checking the whole line. It's still horizontal, so doesn't change, doesn't rotate anything, but it shows you the whole image even from the first points of your scan. And the last option which we are working with is the rotating box. And rotating box looks like this. And with the meeting, you have a box and you're averaging the content inside the box, and you're making a line profile, but the line profile is from the whole box. You can see it right now that we have like sharp edges, but if I will move it a little up. The edge is not sharp anymore because it's still averaging also this like round edges. So this one is much better option for some statistics if you want to measure it and we want to, let's say, averaging few points. That's the way how to change it. Also, if you want to calculate some distance or some for example a vertical distance from the top plateau to the substrate, we are using now the cursor, but you can also averaging the cursor itself with something which calls marker rate. And if I go just click the 9 data points, you can see that right now I have 2 cursors which are actually 1, and we are now averaging the 9 points between these 2 cursors and calculated with 1 number, comparing to the second cursor, which could be also 2 markers which are averaging few points. So you can add more points, so better statistic, better results, better idea about it. So that's about the section. The last point which I didn't explain yet is here the spectra, or its general fast Fourier transformation of the line spectrum. I will prepare a special video about fast Fourier transformation, so I will talk about it in later videos. So that's it. That's about the tilt compensation for measurement, and see you in the next video. Bye.